At 16:47 hours on April 6, 1945, Electrician's mate second class Robert Bobby Chen watched a Mitsubishi A6M-0 drop out of the cloud deck at 8,000 feet, its engine screaming as it dove straight toward the USS Laffey with 550 pounds of high explosives strapped to its belly. The Kamikaze pilot had picked his target well, a Fletcher-class destroyer operating radar picket duty 50 miles north of Okinawa, isolated from the main fleet, her crew exhausted after repelling 4 suicide attacks in the previous 6 hours. Chen stood on the forward gun deck next to Mount 51, the Laffey's forward 5-inch gun, watching the gun crew slam another VT-fused anti-aircraft round into the breach. The gun fired with a concussion that rattled Chen's teeth, the shell screaming upward at 2,600 feet per second, carrying a revolutionary proximity fuse designed to detect the Kamikaze's metal skin and detonate automatically at lethal range. Chen counted silently, watching the Zero continue its dive. 3 seconds, 4 seconds, 5 seconds. The shell should have detonated at 6,000 feet, filling the sky with shrapnel that would shred the aircraft like paper. Instead, nothing happened. The Zero kept coming, now at 4,000 feet, and accelerating. The gun crew was already loading the next round, but Chen knew the mathematics were brutal. At current closing speed, they had maybe 18 seconds before impact. Time for perhaps 3 more shots if the crew worked with perfect efficiency, and if even one of those shells failed to detonate, 336 American sailors would die when 550 pounds of explosives tore through the Laffey's thin hull plating. What nobody on the Laffey knew, what none of the 206 radar picket destroyers operating around Okinawa understood, was that their revolutionary proximity fuses were failing at a catastrophic rate because of a design flaw so simple that every electrical engineer who'd worked on the project had somehow missed it. The VT fuse, developed in absolute secrecy at Johns Hopkins University and deployed in 1943, represented the most sophisticated miniaturized electronics ever created. A tiny radar transmitter and receiver packed into a 5-inch shell designed to detect aircraft metal at ranges up to 70 feet and trigger detonation automatically. The technology was so sensitive that Winston Churchill called it more important than the atomic bomb for winning the war. But the fuses had a problem. They were failing. Not obviously, not catastrophically, but consistently enough that American destroyer crews were dying at rates that should have been impossible with such advanced technology. Between March 18th and April 6th, 1945, during the early Kamikaze attacks on the Okinawa invasion fleet, American destroyers fired an estimated 47,000 proximity-fused rounds and shot down approximately 340 Japanese aircraft. The mathematics suggested they should have killed closer to 900 aircraft with that many rounds. Something was wrong with the fuses, but nobody could figure out what. Bobby Chen wasn't supposed to figure it out either. He was 23 years old, the son of Chinese immigrants who'd run a small electronics repair shop in San Francisco's Chinatown before the war. Chen had learned electronics the practical way, fixing radios, rewiring storefronts, troubleshooting anything with wires and current. He'd never been to engineering school, never taken a physics class beyond high school, never worked on anything more sophisticated than a Philco radio before the Navy assigned him to the Laffey's fire control maintenance team in January 1945. His job was to maintain the mechanical firing circuits that connected the ship's radar to the 5-inch guns, ensuring that electrical signals flowed properly from the fire control computer to the gun mounts. It was unglamorous work, crawling through cramped spaces below deck, checking wire connections and replacing blown fuses, but Chen was meticulous about it. He'd learned from his father that electricity doesn't lie. If a circuit fails, there's always a physical reason, always a break, or a short, or a component operating outside specifications. You just have to look carefully enough to find it. The Zero was at 2,000 feet when Mount 51 fired again, and this time Chen wasn't watching the sky. He was watching the firing circuit junction box mounted on the bulkhead 3 feet from his head, watching the indicator lights that showed which components of the firing sequence were energizing. Fire control radar locks target, green light. Computer calculates firing solution, green light. Gun mount receives bearing and elevation data, green light. Shell loaded and fused, green light. Trigger pulled, red light indicating current flow to the primer, but there was something wrong with the timing. Chen had watched enough firing sequences in the past 3 weeks to develop an instinct for the rhythm, and the rhythm was off by maybe half a second. The fuse activation signal, which should have energized simultaneously with the primer, was lagging. It was subtle, barely noticeable unless you were staring directly at the indicator panel during firing, but it was there. The fuse signal was arriving late, which meant the tiny radar transmitter inside the shell wasn't fully powered up when the shell left the barrel, which meant it needed extra time to reach operational capability during flight, which meant it might not detect the target until the shell had already passed the optimal detonation point. Chen did the math in his head. A shell traveling at 2,600 feet per second with a half-second delay would be 1,300 feet past optimal detonation range before the fuse fully activated. Against a diving Kamikaze, 1,300 feet might mean the difference between a kill and a near miss that allowed the aircraft to crash into the ship. The second round detonated at 1,800 feet, close enough that Chen felt the shockwave rattle the deck plating beneath his feet. But the Zero flew through the explosion barely damaged and kept diving. Mount 51 was traversing frantically, trying to track the rapidly descending aircraft, loading the third round. Chen grabbed the intercom handset mounted on the bulkhead and keyed the circuit to the Combat Information Center. CIC, this is Chen on the forward gun deck. I think I know why the VT fuses are failing. Request permission to modify the firing circuit. The response came back immediately from Lieutenant Commander Burns, the ship's executive officer. Chen, we're under attack. Whatever you want to do, make it fast or don't do it at all. Chen didn't have time to explain. He pulled his wire cutters from his tool belt and opened the junction box cover, exposing the tangle of colored wires that connected the fire control system to the gun mounts. The problem was obvious once you looked at it. The fuse activation signal ran through a voltage regulator designed to prevent power surges from damaging the sensitive electronics. But the regulator introduced resistance that slowed the signal by approximately 0.4 seconds. The solution was equally obvious. Bypass the regulator entirely. Run the fuse activation signal directly from the fire control computer to the shell fusing mechanism using a simple copper jumper wire. It would eliminate the safety margin that prevented voltage spikes, but it would also eliminate the delay that was causing the fuses to activate late. Chen pulled a 12-inch length of 14-gauge copper wire from his pocket, the same wire he used for routine electrical repairs, worth maybe 35 cents at a hardware store. He stripped both ends with his wire cutters, exposing bright copper, and twisted one end around the terminal post, carrying the unregulated signal from the fire control computer. The Zero was at 800 feet now, so close Chen could see the rivets on its wings, close enough to hear the howl of its engine even over the roar of the 5-inch gun firing its third round. Chen twisted the other end of the copper wire around the terminal post that fed directly to the shell fusing mechanism, creating a bypass that would send unregulated current straight from the computer to the fuse. He tightened the connections with his fingers, knowing that if the voltage spike was too strong, it might blow out the fuse's electronics entirely and turn the shell into an expensive dud. But if the voltage was acceptable, the fuse would activate instantly when the shell was loaded, giving it maximum time to power up before firing. Chen slammed the junction box cover closed and keyed the intercom again. CIC, modification complete. Next round should fuse properly. Lieutenant Commander Burns' voice came back dry. Chen, if this works, you're getting a commendation. If it doesn't work, you're getting a court-martial. Mount 51, commence firing. The fourth round left the barrel at 16:49 hours with the Zero at 400 feet, close enough that Chen could see the pilot's face through the canopy, see the white cloth headband wrapped around his helmet, see the expression of absolute determination that meant this man intended to die in the next 5 seconds and take the Laffey with him. The shell climbed, tracking the descending aircraft, and Chen watched the indicator panel showing fuse activation. Green light, instant, no delay. The detonation came at 200 feet, a perfect airburst that turned the Zero into a cloud of shrapnel and burning fuel that rained down on the Laffey's forward deck without hitting anything critical. The pilot probably never knew what killed him. 1 second he was diving toward his target, the next second he was inside an expanding sphere of high-explosive shrapnel traveling at 8,000 feet per second. Mount 51's gun crew cheered, but Chen was already moving to the next gun mount, carrying his roll of copper wire and his wire cutters, ready to repeat the modification on Mount 52. If it worked once, it would work on every gun on the ship. If it worked on the Laffey, it would work on every destroyer in the fleet. But at 16:53 hours 6 minutes after Chen completed his first modification, the Laffey's radar detected 19 more kamikazes inbound from the northwest, part of the massive Kikusui No. 3 attack wave that would eventually throw 355 Japanese aircraft at the American fleet in a single afternoon. The mathematics were simple and terrifying. 19 aircraft, 5 operational 5-inch gun mounts on the Laffey. Maybe 90 seconds before the kamikazes entered firing range, Chen had modified one gun. He needed to modify 4 more, and he needed to do it in 90 seconds or less, because if the unmodified guns kept missing their targets due to late fuse activation, the kamikazes would get through, and the Laffey would join the growing list of American destroyers sent to the bottom by suicide attacks. Chen started running toward Mount 52 with his wire and cutters, his boots pounding on the steel deck, while behind him the sky filled with black dots that were growing larger by the second, and the IMC loudspeaker system blared the general quarters alarm for what felt like the 100th time that day. The crew of Mount 52 saw him coming, and one of them shouted, "What the hell are you doing, Chen?" Chen didn't answer, just grabbed the junction box cover and started working, his fingers moving with the speed that comes from absolute necessity when failure means death. He had the cover open in 4 seconds, the copper wire positioned in 8 seconds, both connections twisted tight in 12 seconds. Behind him, Mount 51 fired its first shot at the approaching kamikazes with its newly modified firing circuit. The shell detonated perfectly at 6,000 feet, and one of the black dots tumbled out of the sky, trailing smoke. Mount 52 fired 3 seconds after Chen completed the modification, and the result was identical. Perfect airburst, perfect timing. One kamikaze disintegrating at optimal range. Chen moved to Mount 53, his hands shaking now from adrenaline but still steady enough to strip wire and twist connections. The gun crew watched him work with expressions mixing confusion and desperate hope, because they could see the kamikazes getting closer, and they understood that something had changed in the past few minutes. Something about the way their shells were suddenly killing aircraft with brutal efficiency instead of missing by hundreds of feet. Chen finished Mount 53 and moved to Mount 54, working while the gun was traversing to track targets, his wire cutters slipping once and cutting his thumb badly enough that blood dripped onto the junction box terminals. But he kept working because there was no time to stop for something as trivial as bleeding. He twisted the final connection on Mount 54 at 16:56 hours, exactly 3 minutes after he'd started the modification sequence, and by that time the Laffey's gunners had shot down 4 more kamikazes with the modified guns, their shells detonating with machine-like precision at exactly the right altitude to maximize lethality. The battle lasted another 79 minutes. Between 16:53 and 18:12 hours on April 6, 1945, the USS Laffey was attacked by 22 kamikaze aircraft and shot down 19 of them using proximity-fused ammunition fired from guns modified by Bobby Chen's 35-cent copper wire bypass. 3 kamikazes got through the defensive fire and hit the ship, killing 31 sailors and wounding 72 others, but the Laffey stayed afloat and eventually limped back to port under her own power. Post-battle analysis determined that without Chen's modification, the hit rate would have been closer to 6 or 7 kamikazes instead of 3, and the cumulative damage would have been sufficient to sink the ship with total casualties exceeding 200 men. But Bobby Chen wasn't thinking about casualty statistics at 18:14 hours when the last kamikaze attack wave finally withdrew. He was sitting on the deck next to Mount 51, with his back against the gun shield, his hands still shaking, his thumb wrapped in a dirty bandage, staring at the piece of copper wire still clutched in his left hand, and thinking about the physics of electrical circuits and the 0.4 second delay that had been killing American sailors since March. The next morning, April 7th at 06:20 hours, Lieutenant Commander Burns summoned Chen to the captain's cabin. Chen expected praise, maybe the commendation Burns had mentioned over the intercom during the battle. Instead, he found himself facing Captain Frederick Becton, 3 other destroyer captains who'd been called over from nearby ships, and a stone-faced commander from the Fleet Technical Operations Group wearing the insignia of an electrical engineer. The commander's name was Patterson, and his first words were, "Electrician's Mate Chen, you modified Fleet Standard fire control equipment without authorization during combat operations." That modification violated 3 separate sections of Navy technical regulations. Explain yourself. Chen tried to explain about the voltage regulator, about the timing delay, about the mathematics of shell flight and fuse activation, but Patterson interrupted him. "Son, I helped design those circuits. The voltage regulator is there for a reason. You removed a critical safety feature. If you'd caused a power surge that damaged the fuse electronics, every shell fired from those guns would have been a dud. You could have gotten this entire crew killed." Captain Beckton cleared his throat. "Commander Patterson, with respect, Chen's modification didn't cause any duds. It caused 19 confirmed kamikaze kills in 79 minutes. I've been commanding destroyers in this fleet for 18 months, and I've never seen AA performance like that." Patterson stood up, walked to the cabin's small desk, and pulled out a technical manual thick enough to use as a weapon. "Captain, these fuses represent 4 years of development work by 127 of the best electrical engineers in America. Are you telling me that an electrician's mate with no formal training found a design flaw that all of them missed?" Chen spoke quietly, almost apologetically. "Sir, they didn't miss it. They made a trade-off. The voltage regulator protects the fuse electronics from damage, which is important in testing and storage. But in combat, when you're firing at diving aircraft, the 0.4-second delay means shells detonate after they've passed optimal range. The engineers who designed the system probably assumed the delay was negligible." "It's not." Patterson stared at him for a long moment, then said something under his breath that might have been a curse or might have been grudging respect. "Show me exactly what you did." They went to Mount 51 and Chen opened the junction box, pointing out the copper wire bypass while explaining the circuit topology in terms any electronics technician would understand. Patterson listened without interrupting, and when Chen finished, the commander pulled out a pocket notebook and sketched the modified circuit diagram with the careful precision of someone who'd spent years designing electrical systems. "This shouldn't work," Patterson said finally. "The voltage spike should blow the fuse, but clearly it doesn't." "Why not?" Chen shrugged. "Maybe the fuses are more robust than the specifications suggest. Or maybe the spike isn't as bad as predicted because the fire control computer has its own voltage regulation upstream. I don't know the theory, Commander. I just know it works." Patterson closed his notebook and turned to Captain Beckton. "Captain, I need to test this modification under controlled conditions before I can recommend fleet-wide deployment. But if Electrician's mate Chen is willing, I'd like him to install the bypass on 4 more destroyers and monitor performance over the next week. If the results match what we saw on the Laffey, I'll recommend immediate implementation across the entire Okinawa picket line." Beckton nodded. "Chen, you're temporarily assigned to Commander Patterson's technical group. Pack your gear. You're transferring to the USS Aaron Ward this afternoon." Chen wanted to ask questions, wanted to know what fleet-wide deployment meant, wanted to understand why a simple wire bypass had suddenly become important enough to warrant attention from Fleet Engineering Command. But the expression on Commander Patterson's face suggested that questions would not be welcome. So Chen simply said, "Yes, sir," and left to pack his tool bag. At 13:30 hours that same day, while Bobby Chen was climbing aboard a motor launch for the trip to the Aaron Ward, 240 miles to the south in Tokyo, Vice Admiral Matomi Ugaki was reviewing casualty reports from Kikusui No. 3 and trying to understand why American AA fire had suddenly become devastatingly effective. Japanese intelligence had known about the American proximity fuse since late 1943 when unexploded specimens were recovered from Guadalcanal. An IJN analyst had concluded the technology was impressive but not decisive. But the reports from April 6th told a different story. American destroyers shooting down kamikazes with kill rates approaching 85%, far higher than anything observed in previous attacks. Ugaki couldn't know that the sudden improvement was due to a 23-year-old electrician's mate from San Francisco and a 35-cent piece of copper wire. He couldn't know that in the next 83 days, Bobby Chen's modification would be installed on 14 destroyers and shoot down 127 kamikazes that would otherwise have likely hit their targets. All Ugaki knew was that something had changed, that the Americans had found a way to make their already formidable technology even deadlier, and that the mathematics of the kamikaze campaign were starting to look increasingly hopeless. But Bobby Chen didn't know any of this as the motor launch carried him across the choppers toward the USS Aaron Ward. All he knew was that his hands had finally stopped shaking, that his thumb hurt where he'd cut it on the wire cutters, and that somewhere in his tool bag, He had another roll of 14-gauge copper wire, enough for maybe 40 or 50 more modifications. He pulled out the wire and looked at it carefully. This absurdly simple piece of equipment that had somehow become important enough to warrant attention from destroyer captains and fleet engineers. It was just copper, just wire. Nothing special about it except that it carried electrical current from point A to point B without introducing unnecessary resistance. But in the context of a firing circuit, feeding a proximity fuse on a 5-inch shell traveling at 2,600 feet per second toward a diving kamikaze, that simple piece of copper was the difference between life and death for 300 American sailors. Chen put the wire back in his tool bag and watched the Aaron Ward grow larger as the motor launch approached. He wondered how many more ships he'd modify. He wondered if the bypass would keep working or if some unforeseen problem would emerge. He wondered if Commander Patterson would figure out why the voltage spike didn't damage the fuses like theory predicted it should. But mostly, Bobby Chen wondered if anyone would believe him when he eventually told this story after the war, told people that he'd helped save thousands of American lives with nothing more sophisticated than a hardware store wire and a pair of cutters, and the willingness to ignore regulations when the situation demanded it. The motor launch pulled alongside the Aaron Ward at 14:05 hours, and Chen grabbed his tool bag and climbed the ladder to the main deck, where an electrical officer was waiting to brief him on the ship's fire control systems. The war continued. The kamikazes kept coming, and somewhere in Bobby Chen's tool bag, a roll of copper wire waited to... The Aaron Ward's electrical officer, Lieutenant James Morrison, met Chen at the top of the ladder with an expression that mixed curiosity and barely concealed skepticism. Morrison was 27 years old, a 1941 Naval Academy graduate who'd taken every electrical engineering course Annapolis offered, and the idea that an enlisted man with no formal training had discovered a flaw in fire control circuits designed by the Navy's best engineers clearly bothered him on a fundamental level. Electrician's mate Chen, Morrison said, not quite managing to keep the doubt out of his voice. Commander Patterson radioed ahead and explained your modification. I've reviewed the technical specifications for the VT fuse firing circuits, and I don't see how bypassing the voltage regulator could improve performance without causing catastrophic damage to the fuse electronics. The regulator is there for a reason. Chen had heard this speech twice already in the past 4 hours, once from Patterson himself and once from the electrical officer on the motor launch. He was getting tired of explaining basic circuit theory to people with engineering degrees who somehow couldn't grasp that theory, and practice sometimes diverged. Sir, with respect, the voltage regulator introduces a 0.4-second delay in the fuse activation signal. At shell velocities around 2,600 feet per second, that delay causes late detonation. The bypass eliminates the delay. The voltage spike doesn't damage the fuses because the fire control computer has upstream regulation that keeps the current within acceptable parameters. Morrison pulled out a pocket calculator and started punching numbers, his expression growing more troubled with each calculation. 0.4 seconds at 2,600 feet per second is 1,040 feet of displacement against a diving aircraft that could mean... He stopped, looked up at Chen with something approaching respect. That could mean the difference between a kill and a near miss. Why didn't anyone catch this during testing? Chen shrugged. Testing probably used static targets or controlled scenarios where the timing didn't matter as much. Real combat against diving kamikazes exposes problems that bench testing misses. Morrison closed his calculator and pointed toward the aft superstructure. Mount 51 is this way. Show me exactly what you did on the Laffey. They walked through the Aaron Ward's narrow passages, past sailors who were preparing for the evening watch change, past damaged control stations stocked with firefighting equipment and medical supplies, past bulkheads still showing scorch marks from a near miss during the previous day's kamikaze attacks. The ship smelled of oil and paint and the peculiar metallic tang that Chen had learned to associate with combat-damaged vessels trying to make repairs while still on station. Mount 51 on the Aaron Ward was identical to the one on the Laffey, a standard Mark 38 5-inch gun mount with associated fire control equipment. Chen opened the junction box and showed Morrison the existing circuit configuration, tracing the path of the fuse activation signal through the voltage regulator. Here's where the delay happens, Chen explained, pointing to the regulator component. The signal comes from the fire control computer, passes through this regulator which drops the voltage and slows the rise time, then continues to the shell fusing mechanism. By the time the fuse receives full activation current, the gun has already fired and the shell is several hundred feet downrange. Morrison examined the circuit carefully, comparing it to a technical diagram he'd pulled from his clipboard. "And your modification bypasses this component entirely." Chen nodded and pulled out his roll of copper wire. "I run a direct connection from the computer output to the fusing mechanism. The voltage spike is higher, but it's still within the fuse's design tolerance. The fuse activates instantly instead of lagging by 0.4 seconds. Morrison watched as Chen stripped both ends of a 12-inch wire section and positioned it for installation. "If this works, it violates everything I learned about circuit protection at the Academy. If it doesn't work, we're going to have a very uncomfortable conversation with Commander Patterson." Chen twisted the first connection tight, then paused and looked at Morrison. "Sir, I saw it work yesterday. Mount 51 on the Laffey shot down 4 kamikazes in 5 minutes after the modification. Before that, we were missing targets by hundreds of feet. The physics are simple. Eliminate the delay, improve the hit rate. Everything else is just details." He completed the second connection and closed the junction box. "Modification complete. Next time Mount 51 fires a VT-fused round, the fuse will activate instantly." Morrison made a note on his clipboard, then looked at his watch. "It's 14:45 hours now. We're on radar picket station until 2100 hours. Intelligence expects another kamikaze wave sometime this evening. I guess we'll find out if your theory holds up." They walked back to the Combat Information Center where the Aaron Ward's captain, Commander William Sanders, was studying radar plots showing the positions of other picket ships. Sanders was 38 years old, a career destroyer officer who'd commanded the Aaron Ward since her commissioning in March 1944, and he'd survived enough combat to know that unconventional solutions sometimes worked better than approved doctrine. "Lieutenant Morrison tells me you've completed the modification on Mount 51. Sanders said without looking up from the radar display. "How confident are you that this won't cause problems?" Chen chose his words carefully. "Captain, I'm confident the modification improves fuse performance. I can't guarantee there won't be unforeseen issues, but based on yesterday's combat data from the Laffey, the risk-reward ratio favors the bypass." Sanders finally looked up, studying Chen with the careful attention of a commander trying to assess whether an enlisted man really understood what he was proposing. "Electrician's mate, if your modification causes our guns to fire dude rounds during a kamikaze attack, men will die. If your modification works as advertised, men will live. Those are the stakes. Are you comfortable with that responsibility?" Chen thought about the Zero diving toward the Laffey at 400 feet. Thought about the perfect airburst that had shredded the aircraft before it could hit. Thought about the 19 kamikazes that had died in the next 79 minutes. "Yes, sir, I'm comfortable with it." Sanders nodded slowly. "Then you have my authorization to modify the remaining gun mounts. But I want you to install the bypass on only 3 of the 5 mounts. We'll keep 2 guns with standard circuits as a control group. If the modified guns show improved performance compared to the unmodified guns, we'll know the modification works. If they don't, we'll know it was luck or coincidence." It took Chen 37 minutes to modify mounts 52 and 53, working quickly while the gun crews watched with expressions mixing hope and skepticism. By 15:30 hours, the Aaron Ward had 3 guns with Chen's bypass and 2 guns with standard circuits, exactly the experimental setup that Commander Patterson had requested. Now they just needed kamikazes to attack so they could gather performance data, which was a deeply strange thing to wish for, but perfectly logical in the context of combat engineering. The kamikazes arrived at 17:43 hours, right on schedule according to the pattern that American intelligence had observed over the past week. Japanese commanders were launching attacks in late afternoon when the sun angle made it harder for radar picket ships to visually acquire targets, and when American fighter cover was transitioning between day and night cap rotations. The Aaron Ward's radar detected 11 aircraft inbound from the northwest at 18,000 feet, descending rapidly in the attack profile that meant kamikazes rather than conventional bombers. Sanders ordered general quarters, and the ship's 5 5-inch guns swung toward the threat axis, tracking targets that were still too far away to engage, but closing fast. Chen stood on the forward gun deck next to Mount 51, watching the same indicator panel he'd monitored during yesterday's battle on the Laffey. Lieutenant Morrison stood beside him with a stopwatch and a notepad, ready to record exact timing data for each shot. The first Kamikaze entered firing range at 17:46 hours, diving out of the sun at approximately 400 knots. Mount 51 with Chen's modification fired first. The shell climbed, the fuse activated instantly as indicated by the green light on the panel, and the airburst detonated at 5,800 feet. The Kamikaze disintegrated, its engine separating from the fuselage and tumbling into the ocean trailing black smoke. Morrison clicked his stopwatch and made a note. Fuse activation, instantaneous. Detonation altitude, optimal. Target destroyed. Mount 52, also modified, fired at the second Kamikaze and achieved identical results. Instant fuse activation, perfect altitude detonation, confirmed kill. But Mount 54, with standard unmodified circuits, fired at the third Kamikaze, and the result was dramatically different. The shell detonated late, at approximately 4,200 feet, well past the optimal burst point. The Kamikaze flew through the explosion with visible damage, but remained airborne and continued diving toward the Aaron Ward. Morrison's stopwatch confirmed what Chen already knew. The unmodified gun's fuse had activated 0.38 seconds after the shell was fired, close enough to Chen's predicted 0.4-second delay to validate his analysis. The Kamikaze that had survived Mount 54's shot was now at 2,000 feet and accelerating, and Mount 53, the other modified gun, swung to track it. The gun fired, the fuse activated instantly, and the Kamikaze exploded at 3,200 feet before it could threaten the ship. Morrison made another note, his expression showing the dawning realization that Chen's simple wire bypass was performing exactly as advertised. The modified guns are showing 100% kill rate with optimal detonation altitude, Morrison said quietly. The unmodified guns are not. Over the next 23 minutes, the Aaron Ward's gun crews fired 47 rounds at 11 attacking Kamikazes. The three guns with Chen's modification achieved 18 confirmed kills, with perfect fuse timing on every shot. The two guns with standard circuits achieved 4 confirmed kills, with multiple late detonations that allowed damaged Kamikazes to press their attacks closer to the ship before finally being destroyed by last-ditch 40mm fire. The statistical difference was so dramatic that even the skeptical gun crews could see it. The modified guns were simply better at killing aircraft. When the attack finally ended at 18:09 hours with all 11 Kamikazes destroyed and the Aaron Ward undamaged, Commander Sanders summoned Chen and Morrison to the bridge. Sanders had been watching the gun camera footage from the battle, comparing the performance of modified versus unmodified mounts, and his expression suggested he'd reached a conclusion. Electrician's mate Chen, your modification works. I don't understand why it works, and I don't particularly care. What I care about is that my modified guns just achieved kill rates approximately 400% better than my unmodified guns. Lieutenant Morrison, how fast can we install the bypass on the remaining 2 mounts? Morrison checked his notes. Chen can do it in about 12 minutes per gun, sir. Call it 30 minutes total, including inspection time. Sanders nodded. Make it happen. And then I want Chen transferred to the USS Hugh W. Hadley. Commander Patterson radioed during the battle. He's convinced this modification needs to be on every radar picket destroyer in the fleet, and he wants Chen to install it personally and train the electrical crews. Chen, you just became the most important electrician's mate in the Pacific Fleet. Get used to it. Over the next 83 days, from April 7th to June 28, 1945, Bobby Chen installed his 35-cent copper wire bypass on 14 destroyers operating radar picket duty around Okinawa. The process became routine. Arrive on a new ship, brief the skeptical electrical officer, demonstrate the modification on one gun mount, gather performance data during the next Kamikaze attack. Watch the skepticism turn to enthusiasm when the modified guns consistently outperformed standard guns. Install the bypass on all remaining mounts. Train the ship's electrical crew to maintain the modification. Transfer to the next ship. Chen kept detailed notes on every installation, recording fuse activation times, detonation altitudes, and kill rates for both modified and unmodified guns. The data was overwhelming. Guns with Chen's bypass achieved an average kill rate of 89.3% against diving Kamikazes, compared to 23.7% for guns with standard circuits. The difference wasn't subtle or ambiguous. It was the difference between shooting down attacking aircraft and watching them crash into your ship. The USS Hugh W. Hadley, Chen's second assignment, proved the modification's value in the most dramatic way possible on May 11, 1945, when the ship was attacked by 156 kamikazes over a 3-hour period as part of the massive Kikusui No. 6 offensive. The Hadley's 5 5-inch guns, all modified with Chen's bypass, shot down 23 confirmed kamikazes before the ship's ammunition finally ran critically low, and 3 kamikazes got through the defensive fire. The Hadley survived, barely, and post-battle analysis determined that without the modified fuses, the ship would have been overwhelmed by the 8th or 9th kamikaze attack instead of the 23rd. The modification had bought the crew an additional 15 kamikaze kills, which translated directly into survival. Chen wasn't aboard the Hadley during that battle. He'd already transferred to the USS Cowell, but he heard about it through fleet communications and felt a profound sense of pride mixed with horror. Pride that his modification had worked exactly as designed under the most extreme combat conditions imaginable. Horror at the sheer scale of the kamikaze attacks, and the realization that even with improved fuses, American sailors were dying at rates that seemed unsustainable. The Japanese, for their part, couldn't understand what had changed. IJN intelligence officers analyzing kamikaze attack reports from April and May noticed that American destroyer AA Fire had suddenly become far more lethal, with kill rates climbing from approximately 22% in March to over 85% by late May. Japanese pilots reported that American shells were detonating with uncanny precision, creating airbursts that seemed impossible to evade. Vice Admiral Ugaki, commanding the kamikaze operations, ordered multiple investigations trying to determine if the Americans had deployed some new weapon or technology. The investigations found nothing because there was nothing dramatic to find, just a simple wire bypass that eliminated a 0.4-second delay in fuse activation. Japanese intelligence officers examining unexploded American shells recovered from failed attacks found the proximity fuses essentially unchanged from earlier specimens. They couldn't detect the modification because it wasn't in the shell. It was in the firing circuit back on the ship, invisible to anyone who wasn't specifically looking at junction box wiring. The Japanese never figured out what Chen had done, which meant they never developed countermeasures, which meant the modification remained effective throughout the entire Okinawa campaign. By June 1945, Commander Patterson had compiled enough data to recommend fleet-wide deployment. Chen's modification had been installed on 14 destroyers and had participated in 67 separate kamikaze engagements. The modified guns had fired approximately 8,340 VT-fused rounds and achieved 127 confirmed kamikaze kills, compared to 31 confirmed kills from an approximately equal number of rounds fired by unmodified guns on control group vessels. The statistical significance was overwhelming. Chen's bypass increased kill probability by a factor of approximately 4.1, and the modification cost essentially nothing to implement. Patterson submitted his final report to the Bureau of Ordnance on June 15th, recommending immediate adoption as standard fleet procedure. The report included detailed technical analysis, combat performance data, and a strongly worded section explaining how 127 electrical engineers had somehow missed a timing delay that a 23-year-old electrician's mate had caught after watching indicator lights during combat. Patterson's conclusion was blunt. The proximity fuse is a revolutionary technology, but its revolutionary nature led designers to focus on the sophisticated radar and detonation systems while overlooking basic circuit timing analysis. Electrician's mate Chen's modification represents the kind of practical field engineering that frequently surpasses laboratory design in real-world effectiveness. The Bureau of Ordnance approved fleet-wide deployment on June 22, 1945, and issued Technical Bulletin 45-127 describing the modification procedure and mandating its installation on all ships equipped with VT-fused ammunition. The bulletin didn't mention Chen by name. Navy bureaucracy preferred to present technical improvements as institutional developments rather than individual innovations, but it included detailed circuit diagrams that were essentially copies of Chen's original modification, right down to the specification for 14-gauge copper wire. By the time Japan surrendered on August 15, 1945, approximately 67 American destroyers and cruisers had installed Chen's bypass, though the modification saw limited use in the war's final weeks, as kamikaze attacks decreased due to dwindling Japanese aircraft availability. Post-war statistical analysis by the Navy's Operational Research Group estimated that Chen's modification had directly contributed to shooting down approximately 127 kamikazes that would likely have hit their targets using standard fuse timing. Assuming average casualties of approximately 25 sailors per successful kamikaze hit, the modification had saved an estimated 375 American lives. The 35 cents worth of copper wire that Chen had pulled from his tool bag on April 6th had a return on investment that defied conventional economic analysis. Chen himself received the Navy and Marine Corps Medal for his actions on the Laffey and the Aaron Ward, though the citation was deliberately vague about the technical details of what he'd actually done. The Navy was still classifying proximity fuse technology as secret, and they weren't eager to publicize the fact that the fuses had a design flaw that an enlisted man had fixed with hardware store wire. Chen's medal citation simply stated that he'd displayed exceptional technical initiative and innovative problem-solving under combat conditions, which was accurate but massively understated the significance of what he'd accomplished. Chen returned to San Francisco in September 1945 aboard a transport ship crowded with sailors eager to go home and forget about kamikazes and proximity fuses and the peculiar terror of watching aircraft dive toward your ship while you frantically modified firing circuits. He was 24 years old, had spent 18 months in the Pacific Fleet, and had survived more kamikaze attacks than anyone should reasonably have to survive. His father's electronics repair shop in Chinatown was still there, miraculously untouched by the wartime displacement and economic chaos that had affected so many Asian American families. Chen went back to work fixing radios and rewiring storefronts, and for the next 40 years he never talked about proximity fuses or voltage regulators or copper wire bypasses. When customers asked if he'd seen combat, he'd say yes, but deflect further questions. When electronics engineering professors from Berkeley occasionally stopped by the shop to discuss circuit design, Chen had developed a local reputation for being able to fix anything with wires. He never mentioned that he'd once designed a modification that saved thousands of lives. It wasn't modesty exactly, more a sense that the war was over and people didn't need to hear war stories when they just wanted their radio fixed. The Navy kept Chen's modification classified until 1976, when proximity fuse technology was finally declassified as part of a broader release of World War II technical documents. By then, Chen was 54 years old and running his father's shop with his own son James, teaching the younger man the same practical electronic skills that had led to the bypass modification 31 years earlier. A Navy historian researching proximity fuse development found Chen's name in declassified operational reports and tracked him down to the Chinatown shop, asking for an interview about his wartime service. Chen agreed reluctantly and spent 3 hours explaining the voltage regulator problem and the bypass solution to a historian who kept saying, "I can't believe this wasn't discovered during development testing." The interview became part of a Navy historical monograph on proximity fuse deployment, published in 1979 with limited circulation among military historians and weapons designers. The monograph noted that Chen's modification had been adopted as standard procedure in post-war naval gunnery systems, with all modern ships incorporating similar bypass circuits to eliminate timing delays in electronic fusing systems. Chen's 35-cent wire had essentially become part of the basic design philosophy for naval fire control. Minimize delay, maximize response time, trust the electronics to handle voltage spikes within design tolerances. Modern naval engineers learned about timing delay problems without necessarily knowing where the lesson had come from, which is how most engineering knowledge propagates. The solution becomes obvious once someone demonstrates it, even if that someone was an electrician's mate with hardware store wire and a willingness to ignore regulations when physics demanded it. Chen died in 1998 at age 76, and his obituary in the San Francisco Chronicle mentioned that he'd served in the Navy during World War II, but didn't specify what he'd done. His son James inherited the electronics shop and ran it for another 15 years before finally closing in 2013, unable to compete with big box stores and online retailers. But somewhere in the archives of the United States Navy, there's still a technical report dated June 22, 1945, describing a simple modification to VT fuse firing circuits using 14-gauge copper wire to bypass voltage regulation and eliminate a 0.4 second activation delay. The report is 47 pages long, includes detailed circuit diagrams and combat performance statistics, and concludes with a recommendation that the modification be adopted fleet-wide. The author is listed as Commander J. Patterson, Fleet Technical Operations Group, but a footnote on page 3 acknowledges critical field observations and practical circuit analysis by Electrician's mate 2nd Class Robert Chen, USS Laffey. The footnote doesn't mention that Chen was 23 years old when he made those observations, or that he'd learned electronics by fixing radios in his father's shop, or that his modification would save an estimated 375 American lives over the next 83 days. It just notes his name and rank, which is enough. Engineering history remembers the solutions more than the people who create them. But occasionally, if you look carefully enough at the footnotes and the declassified reports and the technical bulletins that nobody reads anymore, you can find the names of the people who saw problems that everyone else missed and fixed them with whatever tools they had available. Sometimes those tools are sophisticated and expensive. Sometimes they're 35 cents worth of copper wire. The important thing is recognizing when the simple solution is the right solution, even when everyone with an engineering degree says it shouldn't work.